All right. So, um, yeah. All right. So I want to show you a lot of my, try to keep Canvas up to date. Um, so when you go to Canvas, my home page is going to be modules. What I will do is towards the bottom is the more chronologically more recent. So I just stack that on there. Okay. Um, so on here you'll find syllabus. We're in Unit 1. We did this yesterday, football lab. I just posted the PowerPoint um, for Unit 1. Here's your worksheet, your homework for due tomorrow. On the calendar, it'll tell you that this worksheet is due tomorrow. That's really the only thing that's posted on the calendar is homework stuff. And it'll say 11:59 p.m. is due. I'm lazy. The default is 11:59. I don't worry about changing it for every hour. So it's due that day when you walk into class. So like it's due at like 9:20 on the day on the calendar. Good with that? Okay. Um, so I asked students last year, hey, what's your advice for this year's students? Okay. And this is, I should summarize this, but there's 4 pages. This is unedited. Um, it's like, this is just, I'll summarize quickly for you. Pay attention. You'll do good. If you don't understand something, ask a question. Don't play with your phones, which that's hopefully alleviated. Um, ask questions. Go see Mr. Smiley if you have questions. Take notes. Pay attention. Don't get on your phone. There's kind of some themes there. I mean, you can look over that if you want to, but um, that's advice from your peers. Okay. Here's how I recommend taking notes in this class. I give you the PowerPoint. These two are identical information. One's in a PDF form, the other one's in a PowerPoint form. The PDF, I do that because it meshes better with Google stuff. But if you have PowerPoint at home, Microsoft Office, the formatting would work better for that. I would print out 6 to 9 slides per page and use that as your notes. As we go through class, rather than frantically trying to get factoids down and trying to copy the verbatim what it says on the slides, that you use that as kind of like a template or a staging area for writing notes, things that hit you like, oh, watch for this, or like, hey, I got this wrong, or kind of a journal, if you will, through your journey through the land of physics. Okay. So that was also echoed by people's advice, like take notes, print stuff out. Okay. So kind of some tips from people who've been down this road before. Okay. So that's the Canvas. And I even give you instructions on how to print those slides from the school printers. So that's within the PowerPoint. Okay. All Today we're going to look at converting stuff. So I want to start out with something simple. Is how many dozen do 30 eggs make? Okay, now I'm starting simple, not to like insult your intelligence, but to use something where you're comfortable with to really dig deep into understanding what we do or why we do it. Okay, so mathematically, what would you do to figure out how many dozen 30 eggs make? Yep, we divide by 12 because we know that there are 12 eggs equals 1 dozen. Okay. Now, again, not to insult your intelligence, I just want to like go deep on something that's easy. Okay. So we start with 30 eggs and we do the chemistry thing. Okay. Unit analysis, factor label method, unit conversions, whatever you called it in chemistry. Okay. Here's our conversion factor. 12 eggs is synonymous with a dozen eggs. It's the same thing, right? It's like they're just different ways to describe the same thing. So I'm going to put a dozen on one side, top or bottom, and 12 eggs on the other. It's the same stuff. 12 eggs over a dozen. That's like this over this. This becomes 1. So it doesn't change anything. We're just changing the label. So what am I going to stick on bottom here? What unit? Eggs, because I want to cancel out with here. So I have 12 eggs equals 1 dozen. And so I would take 30 times 1 divided by 12. The answer, you can figure that the process is what I'm focusing on. Okay. You all right with that? So I'm going to dig a little deeper here on the same easy example. Okay. So when we get an answer, would we expect that to be a number that's larger than 30 or smaller than 30? Okay. So what I want you to do is think why you think what you think. What's the reason for your conclusion? Sorry. Let's do this. Or take a time out from that conversation. If you look around you, this is your physics family. Okay. Those adjacent to you, that's your neighborhood. Okay. If you're sitting in the middle, you have the potential to have 8 different neighbors. Okay. Have you ever lived in a neighborhood and you didn't know your neighbor? And that got awkward. Like you see him take out the trash. She goes to the mailbox. Like, okay. I want to destroy that awkwardness right now by embracing a different type of awkwardness momentarily. I want you to introduce yourself to everybody that's sitting adjacent or in your local neighborhood to you. Hi, my name is, nice to meet you. And like, remember these because these are going to be, you don't want to have this awkward scenario later on in the year because this process is going to happen probably about 5 to 10 times a day. So go talk to introduce yourself to your adjacent neighborhood. Hi, my name is. If you find yourself not in a place that's conducive for conversation, you are welcome to move. I do not make you sit in the same seat. So if that requires tapping someone on the shoulder, if that requires turning around, do that. All right. So, a little awkward, but man, that sure saved us a lot of awkwardnesses later in the future. That's a good life lesson right there. The moment you get into a situation where you're like, I'm going to be interacting with these people for could be potentially a lot, you should probably just introduce yourself straight away. Just throwing it out there. All right. So, tell your neighbor why you think the answer you think is the answer, or why it should be the answer. Be more or less than 30. Okay, just a quick timeout. If you find yourself in a neighborhood that you're like, oh, this is not really conducive to conversation, move to a different neighborhood. Totally fine with that. Okay, like we're gonna have these conversations a lot. Okay, so listening, heard a lot of people say it's smaller because you're dividing. That is true, but I want to dig a little deeper. Why? Well, because it's on bottom. Okay, yeah, let's dig a little deeper. Why? Or is it going to be a number smaller than 30?
Because if you divide a bigger number by a smaller number, therefore it can be a bigger number.
True, that's the math, but conceptually. Okay, let's look at the size of the unit. Which is a bigger unit, a dozen or an egg? A dozen. So we're going from a small unit into a big unit. It's describing the same amount, but it takes fewer of the big units to describe the same amount used for smaller units. Does that make sense? Okay, so you're going to end up with a smaller number because you're using a bigger unit to describe the same quantity. You all right with that? Okay. I know I'm just like beating this, but I want you to see why you do what you do. I'm not satisfied with you just doing mathematically. Here's what you do. I want you to dig deep and like, why do you do that? Okay. So I guess another way to say this same thing is don't believe everything your calculator says. You should look at your answer and think, does this make sense? If it doesn't, you did something wrong. Either you punched the wrong button accidentally or you just had a bad setup. Okay? But there needs to be that common sense, that like questioning, hey, is this a thing? Okay? So, quick timeout. This is me just teaching you how I roll. This is how much of my lecture is going to be formatted. I ask you a question. It's in a multiple choice format. Okay? I want you to pretend like this is actually a test, meaning that I don't want you to tell other people what your answer is. Hey, the answer number 3 is A. Like that, you just fail the test right there, doing a move like that. Okay, I want you to answer this independently of anybody else. Okay, take your best stab and come up with a reason why you think so. Okay, the temptation for many of you is to be like, hey, yeah, did you get that too? Yeah, okay. During this first part, I don't want you to influence or be influenced by anybody else but your own thoughts. Okay. After I give you some time, I'll let you converse with your neighbors. Okay. But initially, I want you making your own conclusions. Okay. So, time in. Oh, yeah. Miles. Yeah. Sorry. Is it going to be more or less than 3.1? Like your answer, when you get the answer, is it going to be more or less than 3.1? Like the numeric, like what shows up on your calculator? Yep. Good question. All right. Talk to your neighbor, but more than just say B. Why? Give them a reason. Okay. If you, and don't just like, let's B. Like the louder you shout doesn't mean you make you more right. Like it just means you got better vocal cords. Give a reason. Okay. If people are having different answers, convince them that you're right and they're wrong. Okay. Go.
Actually, I would say you're making this. Okay. No, it's totally irrelevant. Yeah, you're just yapping. It's like.
Okay. What do you say? More? Okay. Because you're going from a big unit to a small unit to describe the same distance with small units. You're going to have a whole lot more small units than your big unit. Okay. So let's give it a shot. How many inches are in 3.1 miles? No one knows that. I mean, that's just useless information. Like, who cares? But we do know some factoids that might help us along the way. Does anybody know any unit conversions that might help us in this process? Yep, we got 12 inches is equal to 1 foot. What else do we know? Okay, 3 feet equals 1 yard. What else do we know? Okay, there's 5,280 feet in 1 mile. Okay, now you're not going to have to memorize these. I will tell you these. Okay, but everybody has factoids in your brain. Some people have more or less. Okay, so we're going to go 3.1 miles. We don't know a conversion factor between miles and inches, but we do know between miles to feet. So every 1 mile is 5,280 feet. And then we then can go from feet to inches. And to get the answer, we just say 3.1 times 5,280 times 12 divided by 1 divided by 1. This. Okay. The answer is going to be big. Should it be big? Yes. Good with that? Okay. So, not too hard. So let's kick it up to something a little bit more like challenging. Let's convert 65 miles per hour to meters per second. Okay. So we don't know what the conversion is, but we know some stepping stones. What are some other factoids, conversion factors that are out there? Oh, hold on, I'm looking for someone that hasn't given something. 60 minutes an hour. And what else? 60 seconds in a minute. Okay.
1,609 meters in a mile.
Yep. Okay. Again, some of those factoids, conversion factors are in your brain. Some of them are not. You will not have to memorize those. I will give you all the ones that you need to know. Good with that? Okay. So, all right, so check this out. 65 miles per hour. See how I wrote that? 65 miles for every 1 hour. Okay, that's a helpful way to start your problem. Okay, so first thing we're going to do, let's go miles to meters. Okay, so down here I'm going to stick what? Miles. So 1 mile is equal to 1609 meters. Okay. Now, if I were to just stop here, what would the units be? Meters per hour. Is that going to be a big number or a small number? Big. Does that make sense? I'm going from a large unit to a smaller unit. Therefore, that requires more of the smaller. Okay. So I've got the meters taken care of. I need the hours converted. Okay. Am I going to stick hours on top or on bottom? On top to cancel this out. So 1 hour is equal to 60 minutes. Okay. And same thing, 1 minute is equal to 60 seconds. Good with that? Okay. Break out your calculators. So everybody needs a scientific calculator, one with sine or cosine on it. If you don't have a calculator, Walmart, $10. I would recommend this version. Nothing personal, and you can use this, but I would not recommend this version. Okay, this one, it does fractions really well, but you really don't need that in this class. Scientific notation, you just have to use a lot of parentheses. It works. Like, I wouldn't get another one. It's just, if you have to go to Walmart and buy one, this one's better than like the other ones are fine. This type of model is it just struggles with scientific notation. Like it's higher maintenance. You just have to put parentheses. It'll work. You just need to know how to do it. Graphing calculators are totally fine. That's the only version that I've seen that problematic. Okay, so go ahead and do that. Hopefully you got 29 meters a second. Here's what mathematically you're doing in a calculator, and you're going 65 times 1,609 times 1 times 1 divided by 1 divided by 1 divided by 60 divided by 60. Here's a popular error. 65 times 1,609 divided by 60 times 60. If you say divided by 60 times 60, your calculator assumes 60 is on top. If you put this in parentheses in your calculator, divided by parentheses 60 times 60 in parentheses, that will work. But if you just have it straight this way, say 60 divided by 60. Good with that? Okay. So that's conversions. Metric system. So you've seen this since junior high. You will not need to memorize this. I will give this chart to you. Okay. A couple of generations ago, having stuff memorized was a very valuable skill. Now, hey Google, we don't need to memorize much. It's readily at our fingertips. But what you do need to know how to do is think. Okay? How to use this is thinking. Okay? What do you do with the facts that are given to you? Okay? So, here's how this works. So these are your prefixes. Let's look at kilo. Kilo. That's very popular. Okay? A kilometer. Okay? What that is 1 kilometer is equal to 1 times 10 to the third meters. Okay. Quick little thing, 1 times 10 to the third, that is 1 with 3 zeros. That is 1,000. If your bank account has 4K in it, what does that mean? Worth it. Crazy. Connections. Okay. So this could be, I could do kilograms. Same idea. 1 kilogram is 1 times 10 to the third grams. Okay. I could do bytes. 1 gigabyte is 1 times 10 to the 9th bytes. So 1 billion bytes. That makes sense? Okay. So let's say I had something nanoseconds. That is 1 times 10 to the negative 9th seconds. 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. This is your base unit, your SI units, your metric, gram, like seconds, meters, whatever. Okay. One of these is equal to that times your base number. Okay. That's how you use that. So let's say we had 57 microliters. First, I want you to think, is that going to be bigger or smaller? Your answer is going to be bigger or smaller than 57. Think without speaking. Have a conversation. Tell them why you think so.
I hope you understand.
Okay. What do you say? Bigger or smaller? Smaller. Okay. You look and it's like, all right, micro. Okay. You're going from a small unit to a larger unit. Therefore, there's going to be less bigger units to describe the same quantity as a bunch of smaller units. Okay. So we're thinking it's going to be less. Okay? So when we do this, we're going to say, okay, micro, this is 1 liter is equal to 1 times 10 to the negative 6 liters. That's our conversion factor. I need to put microliters down below. So 1 microliter is equal to 1 times 10 to the negative 6 liters. Okay. You could use your calculator, or you could recognize, hey, doing this, here's my decimal place. I'm going to move it to the left 6 times. 1, 2, 3, 4, 5, 6. Or you could just go, oh yeah, I know this. 5.7 times 10 to the negative 5th. Liters. Is that bigger or smaller than what we would expect? Sorry, is it bigger or smaller than 57? Smaller. Did we expect that? Yes. Okay. On a test, this will be a multiple choice question. This will be one of the answers. Another answer is going to be this, which is the wrong answer, by the way, just letting you know. Like, okay, I found micro times 10 to the negative 6. I know I need to put microliters down here. I'm going to go like this and that. I know that cancels, and you end up with 5.7 times 10 to the 7th liters. That's what your calculator says. Is that number bigger or smaller than 57? Bigger. And so hopefully you look at that and go, whoa, wait a minute. That answer should be smaller. And so simply because you used common sense, You thought about it. You're like, no, that can't be right. Maybe I need to multiply rather than divide. And so even though you don't know how to do it, you're able to deduce like, hey, wait a minute, that's not right. I should do that. And then you put that answer, not this answer. Check this out. Statistically, a third of you put this. Look to the right of you, look to the left of you. One of you is going to put this. Don't be that person. Okay? Does that make sense? Like, use your brain. You might forget how to use this chart on the test. But if you think through it, like, okay, this is going to do this. Okay? You can figure it out. Okay? That's what I want to teach you, really, is how to think. That's kind of what I'm going for. Okay? All right. You have a worksheet to do tomorrow. Here's how I do homework in this class. It is due on the day, usually the next day. And I don't take late homework. I posted it on Canvas. You can either print that off or you can open it up and do your work on a notebook piece of paper. I will not collect them. Okay, so however it works for you, do that. I will, however, tomorrow walk through the rows and check each person's work. Give you effort credit. Okay, I want homework to be a safe place to try different stuff, learn stuff, like safe place to fail. Okay, and hopefully learn from our mistakes. As I'm going through the rows, I'll post the answer key, and you can check your work. Okay, so I give you points for effort. At some point, it might not be this worksheet, but at some point there will be a question on a worksheet in the future where you won't know how to answer it. You're like, so rather than just like leaving it blank, what I want you to do is I want you to go as far as you can. Set it up, write the variables, do all what you know how to do. And then at some point where you reach that brick wall, you're like, man, I don't know what to do after this. At that point in time, I want you to write a specific statement or a question right there on your homework addressing that point. Okay? It needs to be specific. Here's what I'm going for. There needs to be evidence that there was effort given. Let's just say hypothetically one of your friends, let's say, forgot to do their physics homework. Remembered right before, like, oh, okay, 1, I don't know, 2 question mark. Like, sorry, I tried it. Okay, I'm giving you effort points, effort credit, but there needs to be effort, the evidence of effort on your homework for credit to be given. Does that make sense? I need something specific. Don't write, I don't know. Why don't you know? What is it that tripped you up? Okay? So you got a worksheet due tomorrow.